So I've been doing a bit of load testing, very temporary, of course. Anyway, let me show you what the setup is. So I've just run, this is 6 AWG 3-conductor wire. And this little portable charger will actually handle 32 amps at 240 volts, 7.5 kilowatts. And that is indeed what it's been taking. Presents about a 7.5 kilowatt load, which is close to the maximum for the 12K PV. This is what I installed. This is the number 6 wire, neutral, 2 lines, ground. I've got them connected to the load breaker. And of course the AC coupled solar is going here. And we'll see about connecting to the grid. I'm trying to talk my wife into doing a solar carport out here. It would be a lot easier on the cars. They sit here and bake in the Maui sun. What I'd like to do is just provide a little bit more power to charge, another 10 kilowatts or so. But so as you can see here, this is 4.523 kilowatts coming from the AC coupled, charging the battery, nothing coming out of the inverter. And one of the nice things about doing it with the Tesla is I can directly control when the Tesla is charging from my phone. So I just go in here and crank in a little bit of charge. And these are the in-phase inverters on the solar panels. And then we start getting power charging the Tesla. So we've got 2 kilowatts roughly coming from the PV panels, another 6 coming from the battery, and we're charging the Tesla. So this is my messy shop. This is about as bad as it gets before I spend a couple of days cleaning it up. I've been playing around with different ways to power my Home Assistant. Right now I'm using a Home Assistant Green, which I think is pretty underpowered for this. I've also built this little Raspberry Pi. This is a Raspberry Pi with a 1 terabyte of solid state memory and a good cooling system. I think this is a good candidate for the final system. I have a simpler version here. This is a Raspberry Pi with a fan. It's what I started with. This is Open Sprinkler, which is a capable piece of equipment that'll be managing all the sprinklers we use. And this, of course, is the Enphase Enlighten hub for the Enphase microinverters. These are Arlo cameras. I'm really not going to be using these as cameras, although I may. I may actually connect them so I can see what's going on. Mostly I want these because Arlo has developed some AI software, firmware, that can detect fires, can recognize and trigger automations in the event of a fire. So I will be probably using that as my fire detection. These are ESP32 cameras. I configured a bunch of these. They're a nice little camera for doing a local monitoring. So monitoring the pool pumps and things like that. I've done a number of them, got them configured. These are relays that are easy to drive from these ESP32 boards, which can be configured. This is configured with ESP Home, which is an add-on to Home Assistant that allows these to be directly controlled from Home Assistant. You just supply them with some power. These little boards have built-in Bluetooth and Wi-Fi, and they're programmable just as if they were Arduinos. They have a so I can write C++ code for these and have them do anything I want to do. So we are getting close to putting together the fundamental system that will drive everything. I'm probably, unfortunately, going to have to wait until next year to finish up the installation of everything. This, by the way, this is another Raspberry Pi that I've installed Solar Assistant on. Solar Assistant is a replacement for the external monitoring that is feasible with the EG4 app. And I'm not a complete bug on security, but I do like the idea of things being local, not cloud driven. So both from a standpoint of performance and for security and reliability, you know, having a company go bankrupt or stop supporting a particular piece of equipment is not something I want to have to plan for. So this is where we are. We're up and running, able to produce 8 kilowatts of AC, tested, works. And so that's where we stand right now. So I'm going to go play, and I will see you next time. Bye.